Welcome back, mathematicians. In this video, we are going to learn how to solve trigonometric equations. So a trigonometric equation is one where we have a trigonometric function. We are being asked to find any values of the variable, in this case theta, that satisfy the equation when evaluated for that trig function. And there can be more than one, and oftentimes there is more than one solution. Now, it is also possible that no angle or no value of the variable satisfies the equation, which means that there is no solution. So that is a possible special case scenario. In our example here, what we're trying to do is solve the equation where we're told that theta will be greater than or equal to 0, but less than 2 pi. For our equation here, tangent of angle theta has already been isolated. If it wasn't, we would want to move terms from the left side to the right side if there was a coefficient and or a constant. The first step in doing this, whether you're using the unit circle or going to draw yourself some pictures, which I'll do here in a minute, is you should probably unrationalize the denominator. To do this, let's go ahead and multiply the numerator and denominator by square root of 3. Then we should reduce the ratio to get 1 over square root of 3. This will make your life a little easier if you're using, again, pictures or the unit circle to find angles for theta that satisfy this equation. I'm going to go ahead and draw myself a couple pictures to illustrate this. We know that tangent of angle theta is equal to a positive ratio in quadrant number 1, which means my terminal side must be in quadrant 1. To draw my picture, I know the opposite side is 1, adjacent side is square root of 3, and the hypotenuse or radius will be 2. So I'm trying to find this angle theta here, and so I know angle theta in this particular picture is going to be pi over 6. But I also know that there's a second quadrant that results in a positive ratio for tangent, and that quadrant would be quadrant number 3. So in quadrant number 3, I have my terminal side. My adjacent side, however, is going to be negative 1 because it's in quadrant 3, and the opposite side will be negative square root of 3 because, again, we're in quadrant number 3. But the ratio of negative 1 over negative square root of 3 is still positive 1 over square root of 3. My hypotenuse or radius will still be 2. Now I know that this reference angle, based on the previous picture here, is going to be pi over 6. So my goal is to find this angle here, which is going to be pi plus pi over 6, which is a sum of 7 pi over 6. So I know my final answer is going to be theta is equal to pi over 6 and also 7 pi over 6. Here we have a second example where, again, we are being asked to find angles for theta that are greater than or equal to 0 but less than 2 pi. So we have 4 times the cosine of angle theta plus 2 is equal to 0. Like I said in the last example, the first step we want to do is isolate the trigonometric function. So we'll start by subtracting 2 to both sides, which leaves us with 4 times the cosine of angle theta is equal to negative 2. Now we're going to divide both sides by 4 and reduce the fraction to get cosine of angle theta is equal to negative 1/2. Now what we do is we look at our unit circle and we identify the x-coordinates on the unit circle where our terminal side intersects the unit circle, which are negative 1/2. And there will be 2 angles that satisfy that. Or you can draw yourself a quick 2 pictures, which I'm going to illustrate now. So we know that cosine of angle theta is equal to a negative ratio in quadrant number 2. We also know that the adjacent side will be negative 1 and the hypotenuse or radius will be 2 based on that ratio. This means the opposite side will be square root of 3, and so I need to find this angle here, which is theta. To do that, I'm going to identify the reference angle. Based on this triangle, the reference angle is pi over 3. So that means angle theta is equal to pi minus pi over 3, which is equal to 2 pi over 3. Now that's one of my 2 solutions because I know there is a second quadrant that results in a negative ratio for cosine. So that second quadrant is actually quadrant number 3. And so in quadrant number 3, I also know the adjacent side is negative 1. Hypotenuse is still 2, but in this case my opposite side is negative square root of 3. The reference angle, however, is the same of pi over 3. So now my goal is to find this angle here, which is going to be theta is equal to pi plus pi over 3, which means it's 4 pi over 3. So your two solutions to this equation are 2 pi over 3 and 4 pi over 3. All right, guys, good luck.